All right, in this video for AP Statistics, we are going to look at an example for categorical data in sampling distributions, so sampling distributions for proportions. Okay, so we have a manufacturer of computer printers purchases plastic ink cartridges from a vendor. When the shipment is received, a random sample of 200 cartridges is taken and then each is inspected. If the sample proportion of defectives is more than 2%, the entire shipment will be returned to the vendor. What is the approximate probability, so we're looking for a probability here, that the shipment will be returned if the true proportion of defectives in the shipment is 0.05? Be sure to check the conditions necessary for accurate probabilities. Okay, groovy. So we have a proportion. We are looking for a probability. So we are going to use a probability distribution. What would be swell and easy to use as long as our sample's big enough? It'd be the normal curve. So we are going to go through our conditions. And a random sample of 200 was taken. So you can write something like 200 cartridges represent a simple random sample, or 200 cartridges were randomly selected, whatever you want to do, as long as you mention randomization. And of course, there's no need to worry about each of these being independent from each other. So cartridges are independent as far as we're concerned. And then I don't know how many cartridges were shipped, so I have to make the assumption that 200 is going to be less than 10% of the total. So I am going to say it is reasonable to assume 200 is less than 10% of all cartridges. And then, of course, I need at least 10 that are defective, and I need at least 10 that are not defective to ensure that my sample size is large enough to be representative of the population. So I am going to take NP greater than or equal to 10, and N times 1 minus P greater than or equal to 10. So 200 times 0.05 is going to give me 10, and 200 times 0.95 is going to give me 190. So the sample is large enough to approximate normal. Awesome. Once I determine that, now I've got to find my parameters. So that means that I am going to need what the mean here is, or the average, and it is going to be equal to P. You can also think of this as the center so that we don't get confused later when we start talking about quantitative data and means versus proportions. So the center, of course, would be represented by P, and then the standard deviation is going to be 0.05 times 0.95 divided by 200, which gives me 0.0154. So my distribution looks like this, and that is the distribution I'm going to use to find my probability. Okay, so I want the probability that the shipment will be returned. So if it's returned, that means we find that more than 2% are defective. So 2% is over here to the left. So if more than that are found to be defective, then I will return the shipment. So the probability that P hat is greater than 0.02, and then we can just go to Staplet here. And my mean is 0.05. Dang it. There's already a decimal there. Crying out loud. And your standard deviation is 0.0154. Plot. And then I want the right, oh yeah, to the right. I can read. That would be 0.02. Lovely. And I get 97.43. Score! 97.43%, which stands to reason that the probability would be that high that you would reject the sample, because if in actuality 5% of them are, it makes sense that the probability is high. So you're welcome.